Now the topic is double hashing. We have already seen linear probing and quadratic probing. Those were the methods for resolving collision. So this is also a method for resolving collision. The idea here is we will have two hash function. One is the basic hash function. Then if there is a collision, then the other hash function will help us to remove collision. So for explanation, I have taken an example here. See, this is the first hash function, x mod 10. So that is a regular hash function that we have used in various examples. So h1 is x mod 10 because the size of the hash table is 10. Then this is the second hash function. That r is a primary number that is smaller than the size of the hash table. So the size of the hash table is 10 and less than 10, what is the nearest prime number? That is 7. So r should be 7. I will modify it. So I have modified it to 7. Actually, second hash function is having two desired properties. One is it should never give a result 0. It should not give index 0, first one. And the second thing is it should try to probe all the locations. Means whenever there is a collision, it should not give the indices in the same pattern. It should give different indices such that all the locations are utilized. So for that, the suggestion is this form of hash function with a prime number. So this is the suggested hash function, so we use this one. Or else you can design any other hash function you like. But two things you have to take care. The result of that hash function should not be 0. And the second thing is it should try to cover all the indices. The next thing, we will use regular hash function. If there is a collision, then we will try to use this modified hash function. So let me explain this modified hash function. This is h1, this one, same, plus I into result of second hash function. And this entire result is mod by the size of the hash table. Then this value should be multiplied by I, where I takes the value 0, 1, 2 onwards. So it is similar to linear probing and quadratic probing. So when first time when you are using, I value will be 0. So this is of no use. So we can say that directly we'll use this hash function for first time. Second time onwards, I value will be 1, then this is considerable, then we can use this modified hash function. So for demonstrating double hashing, I already have a key space and the hash table ready. Let us map these keys on the hash table using this double hashing. So let us start. First key is 5. 5 mod 10 is 5 only. So this is mapped on a location 5. So 5 is stored here. Then 25. 25 mod 10 is 5. So this is again mapped on the same location. So this is a collision. Then I should use this modified hash function. Modified hash function for 25 is this result we got it as 5. So 5 plus I should be 1 now. Earlier I was 0. That's why we took directly 5 and found that there is a collision. Now I should be 1 into h2 of x. So I should write down 25 here. So what is the result of 25? I will calculate it. 7 minus 25 mod 7. So this is 7 minus, this is 4. So this is 3. So it should be 3 mod 10. This will be 5 plus 3, that is 8. So 25 should be stored at index 8. So 25 is stored here. Now next 15. See, the keys I have taken all are ending with 5, so they will collide with this index, right? So all are colliding only, so we can see its extreme cases also. So let us map 15. 15 mod 10 is the same index. Collision. Now let us use this modified hash function for 15. The result of this function was 5, so that is a collision. 5 plus, now 1 into, we have to get the result of this function, that is h2 of x. X is 15, so I will evaluate this one. 7 minus 15 mod 7. 7 minus, see, 7 will divide 15 for 2 times, 14, remainder is 1. So this is 7 minus 1, this is 6. So this is 6 mod 10. So 5 plus, 5 is for this one, plus as it is, I is 1, then h2 of x is 6 that I have evaluated here. So this is 11 mod 10. So the answer is 1. So this 15 should be stored at index 1. The next key is 35. 35 mod 10 is a 5. So there is a collision. It will map there only. Then we should use this modified hash function. H dash of 35 is h1 of 35. Just now we got the answer as 5. So 5 plus I should be 1 now into h2 of 35. Let us calculate 7 minus 35 mod 7. So 7 minus, this is 0. 35 will get exactly divided by 7. So remainder is 0. So this is 7 minus 0 is 7. So this is 7 mod 10. So this is 5 plus 7, that is 12. Mod 10 is 2. So 35 should be stored at 2. So one thing to observe here is that whenever there is a collision for any key, when I am finding out modified hash function value, I am getting different locations. In linear probing or quadratic probing, we were getting same location, next plus 1 or plus 4, like plus 1 and plus 1. So every time next location in linear probing. And quadratic probing was giving us plus 1 or plus 4 or plus 9. So it was quadratic. But here every time we are getting different location, though all these elements are being mapped at same index 5. So that's what this double hash function is giving us different locations for different keys. Now the last one remaining is 95. 95 mod 10. So remainder is 5 again. So it will be mapped here only. So for 95 I will calculate here. H dash of 95 is 5 plus, this is 5 plus I should be 1 into h2 of x, that is 7 minus key mod 7. 7 minus key is 95 mod 7. So what is the result here? So this is 7 and remainder if you check, this will be 4. So the answer is 3. See, when we evaluate this answer is 3. For 25 also we got the same thing. Then for 95 we are getting 3 once again. Right? So this is 5 plus 1 into 3 mod 10. This is 8. 5 plus 3, 8 mod 10 is 8. So 8. Now this is second collision. See, for this key we got 2 collisions. Till now we did not get 2 collisions at all. Every time the key was placed at some unique place, that was empty place. So just only one collision was happening. Second time we were getting a free space. But now this is collision once again. Then what I should do? I should calculate the same thing with 2 here. So that's why now I is taking value 2 now. First time 0, that was just 5. Now 1, it has given us 8. Then 2. So this will be 5 plus 6, 11. 11 mod 10 is 1. 1 is already occupied. So again collision. So total 3 collision. 1 at 5, index 5, then at 8, then at 1. So I have to modify this I and take the next value of I, that is 3. So this is 5 plus 9, that is 14 mod 10 is 4. Yes, 4 is vacant. Write down 95 here. So this is the key for which there were more than one collisions. Otherwise, just one collision, second index was valid index or empty location. So this double hashing reduces collisions. So that's all about hashing. So we have seen various hashing methods: chaining, linear probing, quadratic probing, and double hashing. So that's all about hashing methods. So then in the next video, we'll look at hash functions, various hash functions, and also we'll have some general discussion about hashing.